Welcome to Lamar University and this year's JASON event, Operation Resilient Planet. I'm Brittany Janice, a student at Westbrook High School, and your host, Argo. Today's mission will include a visit to the Flower Garden National Marine Sanctuary, which is about 150 miles offshore of Galveston, Texas. Being the northernmost coral reef in North America, the Flower Gardens are a unique marine ecosystem. As a National JASON Argo, I snorkeled over the Flower Gardens with my Argo team and the founder of the JASON Project, Dr. Bob Ballard, and we're going to show you what we discovered. From the Flower Gardens, we will head east of Washington, D.C. to our nation's largest estuary, the Chesapeake Bay. Chesapeake Bay has been a major source of oysters, blue crabs, and other seafood for many centuries. But now, the bay's ecosystem is in trouble and we want to know why. But first, we need to head out across the Texas continental shelf to find the Flower Gardens. It's about an 8-hour trip, so on the way we're going to hear from Dr. Ballard about how he created the JASON Project for school kids like you and me. Also, we're going to hear how being a scientist can lead from one adventure to another. So come with me and let's head offshore.
Every day, everywhere, organisms struggle to survive. From the simplest microbe to the most sophisticated human. They all need a strategy to find food, stay safe, and somehow create the next generation. Meet Dr. Bob Ballard, a National Geographic explorer in residence, your JASON host researcher for this mission, and the founder of the JASON Project. Bob is a world-renowned ocean explorer who discovered the wreck of the Titanic, and during his explorations, he's seen how life thrives in even the harshest conditions.
I've done vertical descents on walls from 50 feet to 5,000 feet without ever losing contact. And to watch that world change is unbelievable.
And now he's leading the Argonaut team in exploring how life survives in the Flower Garden Bank's National Marine Sanctuary, an unusual reef system in the middle of the Gulf of Mexico. Battered by hurricanes and hemmed in by human activity, this resilient ecosystem hosts an amazing variety of corals, fish, and other organisms.
I've done 121 expeditions over the last 40 years. I've been doing it quite a while. And I've seen a lot of things, but the Flower Garden was very magical.
But this magical place is under threat. And to help protect the reefs and wildlife, you first need to observe how the organisms here currently survive and understand how changing one thing, getting rid of one species, might affect everything else in the ecosystem. So, your mission? Discover the competitive strategies within this resilient ecosystem and use that knowledge to see how we can help restore balance to other ecosystems. And to accomplish that mission, you'll need to do the following. Explain how an ecosystem evolves over time. Investigate how organisms compete for resources. Distinguish between different survival strategies.
Well, here we are. You ready for this adventure?
With this knowledge, the Argos can be a vital part of the efforts to preserve this strange and beautiful ecosystem. And for the Argos to really know how the flower gardens work, they first need to know their past. And to do that, the Argos journey miles out into the ocean and eons back in time.
Well, for me, the story of the flower gardens began a long, long time ago, about 150 to 180 million years ago. There was no Caribbean, there was no Gulf of Mexico, there was no Atlantic Ocean. There was this great continent, and that continent began to separate, and as it pulled apart, it created the basin that would become the Gulf of Mexico.
In that vast basin, over millions of years, domes emerged on the ocean floor as less dense salt deposits lifted the sea floor.
As that dome grew, rising from the pressure beneath, it created the substrate that the coral now grows on.
Creates the banks on which the corals can grow.
Yeah.
The coral itself came into being as tiny bacteria gathered together, feeding off hydrogen and carbon trapped by the domes. That bacteria was the pioneering species. Pioneering species are the first organisms to colonize an area undergoing succession. In other words, the first living things in a new ecosystem. In this case, they formed the base for coral growth, and then the coral attracted fish and other creatures.
Well, in many, many ways, the flower gardens are oases of life in a desert of flatness. And this creates the opportunity for ecosystems to develop in a very unique, almost island-like setting.
The process is called primary succession. Primary succession is the beginning of a new community where nothing has lived before. The same process happens in ecosystems all over the world. One species moves in, and other species can then follow. Finally, it becomes a climax community, a later stage of succession that results in a stable ecological community, and usually one that's got a lot of diverse life. Okay, so that's how the reef ecosystem formed. But how do the creatures and plants out in these isolated reefs interact? How do they survive?
So, the conditions look pretty good, so are you ready?
Yeah.
To find out, the Argos need to get a closer look. The Argos are doing a reef fish survey to see what's living out here. They're helped with their fish counts by researchers from NOAA and Texas A&M University. They also use an ROV-mounted camera to sneak a peek at all the creatures around the boat.
There's that barracuda. There's another one. Whoa!
The ROV was probably the most interesting because we got to operate it ourselves, and it was a lot more sensitive than I thought. But it was interesting to see how much different material and data it could collect in such a small little robot.
All that observation and data help the Argos see that life near the reefs uses every possible resource. And one main source of food? Other organisms.
It's a small shark that's kind of following the school. Obviously interested in maybe a free lunch.
The predator-prey relationship is one way organisms get food. In this system, hunters hunt, and the prey tries not to get eaten. One survival technique is using camouflage to hide, or living in large groups so it's hard for a predator to pick off individuals, a strategy the Argos saw out near the reefs.
It was really interesting because there was like 5 or 6 different types of fish, and they were all in schools. And one predator that I saw was about 3 feet long, was the horse-eyed jack, and it was following the barjack and the chubs.
Another way organisms get the energy they need is through mutualistic symbiosis. Mutualistic symbiosis is a relationship where both organisms benefit. One example the Argos can see right beneath their fins, the reefs themselves. Coral is made up of tiny polyp creatures which provide shelter for algae, and the algae give off oxygen, which is useful to the coral. Through these and other coping strategies, organisms tend to find a balance. But sometimes things happen that can disrupt an ecosystem, and that can throw every strategy for survival into total chaos. Some disruptions are natural, such as when Hurricane Katrina came ripping through the Gulf. Other disruptions are man-made and can be much more devastating.
I would think that the greatest threat to the flower gardens are those that could be introduced by humans. Certainly, global warming is leading to an elevated temperature of the Gulf water, which leads to coral bleaching. You also have a tremendous amount of extraction of petroleum and gases in the area.
Coral bleaching destroys the primary building block of the reef ecosystem. And petroleum and gas extraction means the building of huge platforms and the danger of spills. But never underestimate life's ability to turn lemons into lemonade. It turns out the platforms are being colonized by organisms that use the platform's legs to get closer to the sunlight and heat they need.
So the closer to the surface the species can get, the more they will thrive. These legs came all the way up to the surface, so these corals and fish were able to form a home within these structures.
These species are turning a potential threat into a new survival strategy. And what benefits one species often benefits others as well.
In some of these areas, it's like a desert when you don't have any vertical relief, and the little guys have no place to hide. And so if there's no little guys, there's no bigger guys.
It's just like what happened with primary succession millions of years ago, only now it's happening all over the Gulf.
And I noticed as we were coming up, a lot of bait fish and some rather large fish chasing them, so you basically have created an artificial reef.
It's definitely an artificial reef. In fact, there's probably about 3,600 of them in the Gulf of Mexico.
Studying the platform-based reefs, the Argos see just how resilient the reefs are, and they also have the data to back up their observations.
When we were able to snorkel and using the ROV, we had to count and which types of fish there were and which species we saw and how many and how they acted. And that was a major part of collecting the information.
And the more research the Argos do on the reefs, the more they appreciate why this place should be preserved for more study.
Preservation is so critical to the human experience, to the Earth's experience. What we need to really work hard is to maintain that biodiversity.
So let's review what we've learned. We can explain how an ecosystem evolves over time. We've investigated how organisms compete for resources. And we can distinguish between different survival strategies. Now your briefing is complete, and it's time to move on to the next part of your mission.
Go, Jason.
Okay, now we're over the flower garden reefs. Let's jump in and see what's down there.
So, the conditions look pretty good, so are you ready?
Yeah.
Go.
150 kilometers off the Texas coast, the water is clear as a swimming pool. Perfect conditions for our team to survey the fish species near the surface. 20 meters below us, the reef looks colorful, but they are pretty blurry from up top. While we do our fish survey, our scuba divers are inspecting the reefs to see how well they are coping with the environmental stress like hurricanes and ocean warming. So let's go down and see what they're discovering. There are amazing creatures on the reef, like this group of scarlet brittle stars. They climb over the coral heads with their 5 snake-like arms. This speckled squid is using water jets to back off. There is a pufferfish hovering and floating coral eggs. Its needle-like spines are flat now, but she can inflate with water in seconds and make herself inedible. Here is a red and white banded shrimp picking up food. Over there, fish are hiding in crevices between the corals. This camouflaged octopus is scuttling across the reef looking for lunch. It snatched a scallop from a crevice and is off to enjoy the meal in its hideout. These divers are inspecting a loggerhead turtle and making friends with it. There she goes, off to find another resting spot. Now the divers are sending bubbles up to us at the surface. They have proven that the flower garden's ecosystem is healthy and coping with the stresses that are destroying most coral reefs. Well, my Argo team has finished our fish survey on the surface. Let's get back on board and we'll give you our report.
Okay, guys, welcome back. Looked like the current picked up a little bit out there, but I'm really curious. What did you find on the reef fish survey?
Well, we did find quite a few different types of fish, and I know we have a list.
While we were down there, we saw 1 or 2 barracudas, an abundance of chub.
Oh, what does abundant mean?
Over 100, so a big school of fish. And then we also saw an abundance of Creole wrasse, an abundance of barjack. I saw 1 horse-eye jack and 1 yellowtail snapper.
So abundant is one of the categories of the fish that you count, is that correct?
Yes, and they're...
what are the other ones?
The other ones are single, few, and many. And single would be like 1, few is 2 to 10, and many is 11 to 100.
And then abundance is over 100.
I see, great. That's pretty good for just snorkeling on the surface of the reef.
You're right. Although half the coral reefs are showing signs of stress, the flower garden reefs are very healthy. But now we are going to visit Chesapeake Bay and its coastal ecosystem where things are not going so well.
Indeed I am. I'm Chesapeake free. She's the mother of the waters and the people of this land.
It's hard to imagine what John Smith, the first European explorer of the Chesapeake, saw when he sailed into this vast estuary nearly 400 years ago. Shorelines lined with thick forests, fertile plains of grassy wetlands. The skies filled with geese and ducks as far as the eye could see. The water was often crystal clear, revealing a rich bounty of fish. It was without a doubt a sight to behold, abundant with life. But that paradise is long gone, and scientists are increasingly worried that more trouble lies ahead. Kent Mountford, a retired EPA scientist, is an expert on the environmental history of the bay. He and his wife Nancy now spend much of their free time sailing near the mouth of the Patuxent River.
When John Smith came here, he visited this river just about where we were sailing in 1608. There were about 30,000 Native Americans living around the whole perimeter of the bay. Today, the entire Chesapeake Basin is now somewhere in the neighborhood of 16 million. And that's just too much for the system to carry.
Those concerns about the bay's future are communicated to students on board the 18th century replica ship, the Sultana.
Okay, are you guys ready on the halyard?
Ready on the halyard.
The educators on board this historic vessel are not only teaching the students how to sail the boat, but also how to understand how fragile an estuary the Chesapeake Bay is.
What do we call that bigger picture? Does anybody know? The watershed. So let's take a look at that map.
The students are all 8th and 9th graders from Washington, D.C.
Do you know how exhaust affects us?
The smoke.
The smoke, that's right. And the smoke goes up to the sky and it builds up in what?
Clouds.
Yeah, like clouds, and can come down as acid rain.
On this 5-day trip, these students are being taught about the dangers of pollution, as well as the diversity of life in the bay.
This crab's pretty fired up. Throw one in there. Oh, he's angry. Why don't you sit him down in there? We've got some white perch. We've got a yellow perch. We've got an American eel. The eel's really interesting because the eel's born in the Sargasso Sea, and then they travel here. We've got a striped bass, often called a rockfish. Got a lot of different stuff in there. What do you think that crab's trying to do? He's all jumpy, he's snappy. Look. Did you see that? He's angry. What do you think he's doing when he does that? What's he trying to do? He's trying to protect himself, that's right.
Roland Fornoff is the Sultana's education director.
You know, we find that the more interaction kids have with fish and crabs, the more they play with that, they touch that, they see that. So the more interaction they have with that, the more knowledge and basis they have to be concerned about the health of the bay.
Heave! Ho! Heave! Ho! Heave! Ho! Heave! Ho! Heave! Ho!
It's only been in recent decades that people in the watershed have begun to be concerned about the bay's health. In 1983, the federal government and the states in the watershed made a commitment to clean up the estuary under the Chesapeake Bay Agreement, and since then, progress has been made. But decades of virtually unchecked growth have taken a heavy toll, leaving the bay over-fertilized with too much nitrogen and phosphorus, the water murky and turbid, filled with sediment, requiring the Army Corps of Engineers to dredge the muddy bottom to keep harbors, like the Port of Baltimore, open. In the summer months, research divers collecting samples of oysters can barely see 5 feet ahead of them. Due to the high levels of nitrogen and phosphorus, some parts of the bay now have low oxygen conditions, choking off underwater life. Maryland watermen like Chuck White have seen their catch of crabs drop steadily over the years. This past year was one of the worst on record.
As far as what I've seen over the past 20 years, it's definitely declined by far. I don't really know the reason why. I think it's got a lot of reasons.
The reasons for the bay's decline start far away in the rivers and creeks of Maryland and Virginia and the picturesque dairy farms of Pennsylvania, as well as the culverts and drainage ditches of major cities like Washington, D.C., Baltimore, and Norfolk, Virginia. Like veins and arteries, these rivers and streams carve their way through the 64,000 square mile Chesapeake Bay watershed, carrying with them all kinds of pollutants, nitrogen, phosphorus, and sediment, inexorably moving to the Chesapeake Bay, the heart of this vast ecosystem. With all this water comes sediment and fertilizer from farms and lawn runoff, sediment and toxic pollutants from stormwater draining from shopping centers and city streets. All of this gets carried into the bay.
Pull this stuff back and start getting fish out. We don't want any of them to die. I think it's really hard to convey the information that there's not enough crabs in the bay, there's not enough oysters in the bay. What you can do is let them know the problems that are affecting the bay and what they can do to help.
Crystal Marshall says she now understands how we are all affected by the health and survival of the bay.
There's a food chain, and it's like we're at the top, so whatever happens to the water and the fish and stuff happens to us.
I'm gonna give you a compass course now. And a compass course is 180. You want to stay on 180.
400 years ago, when John Smith sailed in these waters, the bay was virtually untouched by man. Few believe that this estuary can ever be restored to what it was like back then. But many scientists believe the bay can be brought back to a much healthier state than it is today. Walter Boynton.
I'm not interested in trying to get all the features that were here when John Smith sailed up the Chesapeake. I don't think that's realistic. But we certainly can do better than what we're doing right now. And we've had successes, and we know it can be done.
Go ahead and take that last wrap off. Let it go slack.
For the young crew of the Sultana, who have traveled back into time on this historic 18th century vessel, their journey now lies in the future, a future that over the next 30 years will be filled with important choices about nothing less than the destiny of the Chesapeake Bay.
Stand by, jibe. Let's go half left. So take it in your main. Jibe ho!
Now you've seen the problems Chesapeake Bay is facing and why the oyster harvest has dropped to 1% of past years. And the bay's blue crab harvests are only half the size they were 15 years ago. This shows why we must protect our bays in Texas so that this does not happen here. 2 years ago, our Texas Wetlands Argos investigated the Trinity Bay ecosystem, and this is what they found.
At Trinity Bay in Anahuac, Texas, students line up to board the Smith Point for the chance of a lifetime. A chance to be a scientist, an explorer, and a discoverer. Today, it's their job to find out what lives beneath the surface of Trinity Bay. They use binoculars and maps to investigate their surroundings. The students learn that Trinity Bay is an estuary.
An estuary is pretty much where saltwater and freshwater meet. It's a mix pretty much of both environments.
An estuary is an area where fresh and saltwater mix, and it happens to be a nursery ground for many species that live out in that area.
Through a process called seining, they find dozens of tiny creatures that live in the estuaries. From shrimp to comb jellies and parasites to fish, these students have discovered life below the turbid waters.
Yeah, they were seining and they were going against the wind and they caught this small mullet.
My best experience on this trip was going through the marsh and seeing what kind of organisms lived in there and how we could help it maintain the habitat in that area.
We find all kinds of species here, from clams, oysters, shrimp, flounder, trout, and those of course go on up to your bigger species and go onto the land with all of your seabirds, geese, ducks, ibis, all kinds of other birds.
Wetlands are extremely important to the health of our planet. They provide many services for the ecosystems, not only for the animals and plants that live here, but also for animals and plants in other parts of the world and throughout the ocean.
Students also got a chance to measure the salinity and turbidity of the water.
All right, right now we're checking how much salt is in the water right here. Salinity? The salinity of the water. And right here there's 11.6, or 11.2, 11.5. Just have to wait for it to settle down. About 11.5, that's the salinity of the water right here.
And we're ready, so go ahead and take our measurement. Lower it till you can't see it anymore, or can't tell the difference. One more. There. Okay, stop.
About 22 centimeters.
22 centimeters. Now, what did we say turbidity was?
Suspended particles in the water.
Okay, the amount of suspended particles. Now, we can only see 22 centimeters down. What if we were in Florida?
You can see like 30 feet.
Okay, much different, because their turbidity is more or less? Less turbid water. So the turbidity here, does that mean that our water's polluted?
No. It could be like nutrients or...
And minerals.
That's right. We've got all the sediments, nutrition, and that's what allows our marshes to be so productive.
The best thing I learned today was pretty much the effect that the percentage of salt water has on the effect of life. The more salt water that's in the water, it kills certain plants, and if those plants are around, then that enables certain animals to live in that habitat as well.
The students help restore and preserve the wetlands by planting California bulrush and other plants.
Today, I guess the best thing to do today was probably whenever we went and used the seine to catch all the little fishes, and then we went and planted some of the plants. It was pretty fun digging the hole in the water and just being all out in the marsh area.
If we're going to leave something for our children, then we need to make sure that those nurseries are intact. And the only way sometimes that we can do that is to restore what we've already damaged.
Now that the expedition is over, these students can take with them an appreciation for the wetlands and all the creatures that live here. The students can now call themselves explorers, discoverers, and restorers.
Our Argos found that the Trinity Bay ecosystem is very healthy, but we need to make sure that tomorrow's pollutants do not overload our bays the way they are killing Chesapeake Bay. Thanks for stopping by this year's Jason's mission. Remember, Jason needs Argos just like you to fulfill national Jason missions. If you would like to apply to be a national Argo like me, visit the Jason website at www.jason.org for details. And don't forget to stop by next year for an energy-filled Operation Infinite Potential.